You know, farming is one of the oldest jobs in the world, but it is getting a major tech upgrade. Today, we're going to look at how some pretty complex systems can give farmers simple, powerful advice right there in the middle of their fields. And our case study for this is Project Green Mitra. It's a fantastic question, right? How does a farm actually get smart? It's not just about having a tractor with GPS. No, it's really about data. It's about taking the guesswork out of these huge decisions, like exactly how much fertilizer to use. So, how do you actually connect a farmer, a little sensor stuck in the soil, and this powerful computer brain that lives in the cloud? Well, let's find out. So, here's our game plan. We'll start with a tool that helps us see how this whole system works. Then, we'll follow the data on its journey, from the field to the cloud and right back to the farmer. We'll get a close-up look at the hardware, see how the system stays smart, and then we'll tie it all together. Okay, so to really wrap our heads around how all these different pieces talk to each other, engineers use this special kind of map. It's called a sequence diagram, and honestly, it's the key to unlocking this entire process. The best way to think about it is, well, it's literally like a chat timeline, like in a group message. You've got different people in the chat, and you can see exactly who said what, who they said it to, and the order it all happened in. It's a really simple but kind of brilliant way to see a whole conversation between machines. So, as we look at these diagrams coming up, just keep an eye out for three basic things. You'll see these vertical lines. Those are the actors, or the different parts of the system. Then you have the arrows going back and forth. Those are the messages. And the whole thing just flows from top to bottom, showing you the exact order of events. Simple as that. All right, enough theory. Let's put this into practice. We're going to follow one simple action. A farmer testing their soil. And we're going to see the absolutely incredible digital journey that one little test kicks off. And here it is, that whole journey all mapped out. Now, I know it might look a little complicated at first glance, but just remember that chat timeline analogy. We've got the farmer, their app, the IoT device in the field, the cloud, and this advisory engine all talking to each other. So let's just break down this conversation, step by step. So the whole thing starts pretty simply. The farmer opens the app, puts in their login info. The app sends a quick message over to the cloud server, basically asking, hey, is this person who they say they are? The server checks its list and messages back, yep, they're good to go. Boom, login successful. Okay, now we're out in the actual field. The farmer tells the app, all right, I'm testing the soil for my corn crop. That command wakes up the physical device. Its sensors immediately get to work measuring all the important stuff in the soil: nitrogen, phosphorus, potassium, moisture, and temperature. And what's really important is that it shows those raw numbers right there on its own little screen. And this is where the magic really starts to happen. The device bundles up all that soil data and zips it over to the cloud. The server then acts like a messenger and passes it to what's called the advisory engine. This is the real brain of the whole operation. The engine already knows we're testing for corn, so it pulls up the ideal soil conditions for that specific plant. Oh, and just to be extra smart, it also grabs the local weather forecast. So now the engine does the math. It compares the field's actual soil data against the perfect, ideal standards, and it even factors in the weather. From all that, it calculates exactly how much fertilizer is needed right down to the pound per acre. It wraps this all up into a simple report, sends it back to the server, which then pushes it right to the farmer's phone. All that complexity turned into one simple, actionable piece of advice. Now, that whole process we just walked through, it totally depends on that little device the farmer is holding in their hand. So let's zoom in a bit and see how that piece of hardware is designed to work reliably, even when conditions are, well, less than ideal. This next diagram is all about the device itself and its sensors. It really shows us how the hardware is built for the real world of farming, where, let's be honest, a good internet connection is not always something you can count on. So when the farmer flips the switch, the device's main chip, an ESP32, immediately pings each sensor. It's like a quick roll call. NPK sensor, you there? Ready. Moisture sensor, you good? Ready. Once every sensor checks in, the home screen pops up. The device is ready for action. The farmer sticks the probe right into the dirt and hits the start button. The main processor then goes back to each one of those sensors, but this time it says, okay, give me the data. It collects all the values, N, P, K, moisture, temperature, and displays everything instantly on the screen for the farmer to see right then and there. And this, right here, this is the crucial part. The device immediately checks for an internet connection. If it finds one, great. It sends the data straight to the cloud and tells the farmer data synced. But, and this is the brilliant part, If there's no internet, which happens all the time in a field, it doesn't panic. It just saves the readings to its own internal memory and shows a little message, saved offline, will sync later. This design is fantastic because it means no data ever gets lost. So the advice is only as good as the data that's driving it, right? So how does that advisory engine stay current with the latest agricultural science? Well, that's where the humans come back into the picture. This last diagram pulls back the curtain a bit. It shows us the people working behind the scenes. We've got admins and agriculture experts, and they use a web portal to manage the system's core knowledge base. This is how they make sure the advice given to farmers is always accurate and up to date. Okay, so the admin's job is to manage the fundamentals. They log into a portal, and from there, they can add new types of crops to the system, maybe edit their names or remove old ones. Every single change they make is saved right to the central database that the entire system relies on. Then you have the agriculture expert, and their role is a bit more scientific. They log in to update the ideal nutrient levels for every crop. So let's say new research comes out on tomatoes. They can go in, tweak those ideal NPK numbers, and save the new standards. The very next time a farmer tests their soil for tomatoes, the advisory engine will automatically use that brand new cutting-edge information. So when you connect that farmer out in the field with that rugged offline-first device and that dynamic expert-led brain in the cloud, well, you end up with something that is truly powerful. So why does a system like this work so well? First, it's robust. It's designed for the real-world conditions of a farm. Second, it's dynamic. It's always being updated with the latest science so the advice never gets stale. And most importantly, it's empowering. It takes this storm of complex data points and transforms it into a single clear piece of advice that can literally save a farmer money and help them grow more food. You know, this whole system is just such a powerful example of smart, thoughtful design. And it kind of leaves you wondering, right? From medicine to mechanics, what other critical, hands-on jobs out there could be made so much simpler and so much more effective with this kind of connected thinking?